Hello everyone, my name is Mohammed Radwan. I'm a Visual Studio ALM MVP and DevOps Practice Lead. In this series, we are going to understand and learn more about microservices and containers. And in this video, we are going to understand what drives the existing of the containers. So we will go through the first is the traditional architecture vs the microservices architecture and why we go for this architecture first in the first place. And we will see some of the real example of microservices architecture. We will go also to understand some of the containers technology like Docker, for example, and understanding some of the orchestration technology like Docker Swarm or Kubernetes, and using some of the registry or a hub for the image or the container images like Azure Container Registry or Docker Hub, and we will go to understand more about Azure Container Services, which are provided by Azure. And we will going to understand that both we can have all of that on Linux and Windows. We will go deeply also to understand the container vs virtual machine and the new model or the new technology which introduced by Microsoft is the Hyper-V containers. So let's see that. So when we look at the microservices vs traditional approach, in the traditional approach, we usually have application architecture as larger service. So we have most of the application running in a single process with different layers. And if we want to scale that application, we scale that by cloning the application on another server or virtual machine or containers. If we look at the microservices, it's just a segregation of the functionality. Instead of one application, it will be multiple small applications. And if we want to scale out, we deploying independently on replicated services across servers, VMs, containers. So for example, if we look at the traditional application, usually it has three tiers approach, or if it is like using its own database, or if it is a single application process, which is what we call monolithic application or using a monolithic database. And this is a traditional application that all the code inside one application. On the other side, which is the microservices, we have segregation of the services. So we have presentation services that consume different either stateless services or a stateful services, and all the service exposed through an APIs and very small services. So looking at that, we will find that we will have like customer services, profiler services, account services, register services, and product services, and we end up with many services. So if there is a real example for that, yes. If we look at Amazon microservices or Netflix, you can imagine every dot of what you can see here is a microservices. So if we look at that, we can understand how we are going to host all these services and how we can manage the hosting of these services. This is a key question now. So are we going to create a virtual machine so we can host every service on a separate virtual machine? It will be just imagine the number of virtual machine I need to maintain and manage. But the best option for hosting microservices is containers. And we'll understand why. Containers and orchestrations. So if we really have a good architecture of our application, we will end up with many bunch of microservices that we need to run each one on containers. So we will have at the end many containers, we need to manage them. So, and the ability to manage them and to have clustering for them. So, like to have reliability about if something went wrong with one, so reschedule that and all of that. This is orchestration. So usually when I'm talking about orchestrator and clustering tool for containers, we have many containers, and this container running on nodes, which is the endpoint that this container will running on, and the orchestrator and clustering tool will try just to manage which container running on which node and reschedule that, monitor the health. Many features depend on the orchestrator tools or orchestrations tool that we are going to use with that. And we will introduce some of the orchestration tools that exist in the market right now. Now we get an overview, so let's start by getting more information. What is a container? So if we look at this definition, container is a lightweight time runtime standalone. So it is a completely standalone or self-contained execution environment. So it's a complete environment that shares the kernel of the host operating system, which is very, very important keyword. It's sharing the host operating system, it's sharing the OS. So the kernel is shared across the containers. And the container include everything needed, all dependencies to run needed application. So it has everything needed to run your application. So it has the code, the runtime, the system tool, system library, setting, everything, and available for both Linux and Windows. Of course, it introduced and it worked from very old with Linux, but now it's working with Windows as well. Microsoft has some partnership with Docker and also implemented that in Windows, as we will see. Containerized software will always run the same regardless of the environment. So if you take the container to run on another environment, it will run the same because it's isolate the software from the surrounding and providing a very well isolation, which give also the ability to scalability very easily. Just imagine how you scale the VM by adding more memory, but in the container, the scalability is even more easier. So the result at the end is something feel like a virtual machine, but remove all the weight of the startup overhead because there is no operating system on the container because it share the operating system from the host machine that hosts the container. So this is the main idea of the container. So if we go to see the difference between container, VM container and Hyper-V container. So when we're looking at the virtual machine, this is what we usually work with. So we have the operating system, the hypervisor, and the guest OS. So I can have a virtual machine with an Windows, for example, and I have another virtual machine with Linux on the same host. So I can, as we can see in the virtual machine, it has its own operating system, which is the guest OS. But when we're talking about container, no, we're using the operating system, the container engine. It, it shared the operating system across the containers. So I use a shared kernel between the containers, which is again remove this overhead. It's either for the space or for the startup and for the stop and all of that. So the Hyper-V container, you can think again, is something between the VM and the container. So it will be a container, but it doesn't share the operating system. So it will has its own operating system. But here maybe it could confuse because if it has its own operating system, it means it is a virtual machine. No, it is not a virtual machine. It has operating system, but it optimized for the container. Why we need any one of them? Again, while the container is very good, but at the end it shares the same kernel, So if you want to work on a multi-tenant environment, then container sometimes is not the best solution, and you will need a virtual machine. But the virtual machine is really, as we, um, it's expensive for the time and for the space. So in this case, Hyper-V container will be much better. So I mean, it's just a new technology by Microsoft for something between the container and the virtual machine, which is the Hyper-V containers. So again, think of it as a virtual machine inside the virtual machine. This is exactly what's the Hyper-V container. I'm not going to talk about Hyper-V container more. I will focus more on the containers and leave the virtual machine or the Hyper-V containers for maybe for other series. So let's understand here the difference between VM and containers. So if we look at the VM, it has a separate OS, but in the container, a shared OS or kernel. The VM larger size compared to container, because again, it including the operating system, but the container is less size because it doesn't include this part of the operating system size. Uh, in the virtual machine, we need minutes to create and provision. If I have, for example, a template, virtual machine template, and I need to create a virtual machine from the template, I need minutes to provision and creating that. But when I'm talking about container, it just no need even to provision, because if I have the image, I can run it and it will be a container. So this is why I don't need even to create a provision. Minutes to start or to stop. Just to try to stop or start your virtual machine and look at the time that needed to start the virtual machine. But when you look at the container, it's just a second. You run your container, it start, you stop, it stop. So it's very quickly. I know that some people thinking, okay, it's not that like minutes and second. When we will look at the DevOps and the practices, when we look at the other picture and perspective of the DevOps, yes, it's really matter. So if we think also again from the number of virtual machine I can create on a hosted machine and the number of container I can create on a physical or a virtual machine. So we can see that, of course, with the container I can create maybe 3 times the number of the virtual machine I can create it on one machine. So this is some of the comparing value, so we can understand why we think of moving or using container VS or over the virtual machine. So why containers again? So if we think again the time to build the new feature, let me tell you, when I look at many companies, they're using monolithic application and they are struggling for DevOps practices. Why? Because just imagine if you want to fix a bug, you will fix that and you need to rebuild the complete solutions because it's just a monolithic application. In many cases, I saw that in real scenarios and real cases that the application build took like 1 hour or 2 hours to complete it. And in many companies, I saw that they have a nightly build which builds the application and prepares that for the QA team next day because, and of course, if something happened wrongly at the build at the night, the QA team next day stay without any work because the build is not ready for test. Also, if I want to have uh, like multiple teams, agile teams, that they are working on the same monolithic application, this is really difficult because just changing here will affecting other teams and so on. But when I divided my application into many microservices and each team will be responsible for one or couple of microservices, and then they can have really a short life cycle for developing new feature or fixing bug, then I can have that which will be deployed on a container, like each microservices will deploy it to a container. So having this architecture with that model, with microservices, with the container is give me the best solution for having a shorter life cycle for developing, which is reducing the lead time for our development lifecycle. Frequently deployment and deploying that, you will find that container is the best solution. Once you go for this model, you will need containers. You will find that that container is really uh, again, it's the best solution over virtual machine, for example. Time to deploy, because again, if we think about the time we needed for deploying, and because we have everything in the container, then we can move the container across different hosts without really worry about if it will work or not, because I have the container itself. It is the same that the virtual machine. I will just give you that and you will just run the virtual machine and the application will run. So the same with the containers. So the time for deployment also, it's become with the time needed for start stop the container. This is also reduced very good time for that. Time to test. So once the deployment is become much quicker, the development is much quicker, then the test will be also, they get the build very frequently, then they can test and verify that. So, and the flexibility between moving between hosts, as I explained, also scalability. I can scalable that container very, very easily, more than even the easier, more than scalability for virtual machine. And the dependencies, container has all its dependencies, so it can just take this container running on any environment and it will work the same as the virtual machine. So container vs image. So the, the first point is to understand what is the container and what is the image. So if the running instance of an image is called a container, so the image, just think of the image is a class and the container is an instance of this class as an object. So I have the image, and when I run it, it is a container. And this is why I can run many container of the same image. And usually the image is set of layers. So the image is designed to be a base image and added layers. With these added layers, it add a functionality or add, let me give you an example. I have a base layer with Windows, for example. And then I will add a new layer with IIS. And I will add a new layer with my application installed. So it will be the base image with the layer. And the main idea for that, because it's allowing to the minimum amount of data to be sent when I want to, like, for example, if I want to transfer the new image, then it will only transfer from one, I mean, transfer this image to another place for registry, for example. Then it will only transfer the delta between the images. And this, of course, will give a very quick transferring that. So Docker. So Docker is a leading open source containerization platform considered as a container technology or engine, which is a utility that can efficiently create, ship, and run containers. This is a Docker. And when we look at the container architecture, and we can see that this is where, and this part is the container engine. This is where exactly Docker sit in. It's a Docker engine or a container engine. Let's start by talking about container deployment workflow. So as we explain the image and the container, so usually I have an image which is a base image, so which is like only one step. As we can see, this image is steps, so I have only one step. Then I run this image. When I run this image, now I have, as we can see, this run the image. So I have here the container. I can stop, start, restart the container. Okay, so this is the first. I have image, I run this image, I got the container. Now I have got the container, which is one layer at the beginning, base layer. Then I start adding something to this container, adding layer, like I have a base image of Windows. So I start adding enable the IIS, for example. Then I commit that, which adding a new layer to the image, which is another one step. Then now I have a new image. So I will tag that with like IIS. So my image now is two layers, the base layer and the new layer added, which is IIS, and then tagged with IIS, then push that to a registry or a Docker hub, which is a Docker hub is provided by Docker website, or I can use Azure Register container registry, which is just a cloud place that I put my image, so I can pull that. As we can see, I can pull this image at any time and then running that as a container in any place. So this is usually is the steps as we can see. Run, make the change, commit. And one of the change, for example, is, let's say I have the IIS, I have another, uh, now I have the IIS, I have my application, I deploy my application to the IIS, and then I commit that to the image. Then I have a new image now, which adding another layer, which will be this layer with the deployed application version 1.2. And I will tag that. So I have this image now, push this image to the registry, and then later I can pull this image and running in any place to run this container. Um, this usually is the workflow. Remember that I can make any change on the container. If I didn't commit that change, it will not be committed on the image. So remember, it is not like not every change I make on the container it will be committed. No, I have to commit the change. So for example, when we look at the virtual machine, usually in the virtual machine, if you do something and save, this will be saved on the hard disk. But in the container, it is not. You just need to commit that it changed. So if you stop the container and rerunning the image, it will go back to the previous state because you didn't commit that it changes on the, the image. We have also the build, which is Docker file, because we have two modes when we running the container. You can have the interactive mode, which is usually like, I want to be like human. I want to like start giving some command with my hand typing. This is what we call interactive. Or we have the build mode, which is like we have Docker file and we give all what we need in a file, and then giving that file to start building the image that we want with that. So this is the workflow for that. Of course, I can using backup for backupping that images as well. Azure Container Registry. I think we understand now this is just a place on Azure, provide services on Azure that it gave me ability to a place so I can put my images and we can pull that images later and running a container on any place, and it support most of the container technology. So here is like pushing and pulling from the Azure Container Registry. When I'm looking at Docker Swarm, as we explained, as I will end up with many containers and I need nodes to run all of them and orchestrate that, then we will look at Docker Swarm, which is a clustering and scheduling tool for Docker. For Docker. So we can establish, manage, and cluster of Docker nodes as a single virtual system. So Swarm assigns containers to underlying nodes. It's managed like this container will be on this node by automatically rescheduling container workloads. Like this is better to be run on this node now. This is scalable, so it's just scalability and clustering orchestration tool. So when we look at Docker Swarm again, this is the main idea. We have Docker client, come with toolbox, and then we have the Swarm Manager, orchestrate deployment and replication across Swarm nodes, because I have many nodes of Swarm. And the Docker Hub, whereas I push my the repository where I push my image and pull my image. And the Swarm node, this is an instance of a Docker that runs a container. When we look at Kubernetes, is the same as Docker Swarm, but with more functionality. Kubernetes is a cluster orchestration system which is developed by Google. Uh, they they use develop this tool for their own to manage and orchestrate their microservices inside Google, and it's become like with more feature, like for example it has a service discovery, application health checking, replication, stage rollout. So it gives more functionality for orchestration and manage containers and nodes. Um, Azure Container Services, or AKS, which is it's a services by Azure, which gives the ability to build a scalable container place, and behind the scene this using all available technologies. So if you can work with Azure Container Services is either with Swarm if you would like that, or you can work with DCOS, which is one of the orchestration tool as well, or if you would prefer to work with Kubernetes as well, you can choose that. So it's just a container services providing by Azure, and give you the ability to have your preferred orchestration tool underneath of that, and give you a very well dashboard and managing that. And behind the scene, when we creating Azure Container Services, I can choose which, not which, how many agent, which is usually the number of virtual machine, and then how many nodes I need. Like I need 3 agent, which is 3 virtual machine. So this is the Azure Container Service will have 3 virtual machine agent, and then on this agent I will have let's say 100 nodes, and then I will running my containers inside these nodes and orchestrating them using, for example, Swarm or Kubernetes. So it just again managing container services in a scalable way as very easily with Azure Container Services. At the end, I would like to thank you for watching the video. Please, if you have any question, don't hesitate to contact me on my blog mohammedradwan.com. Also, you can visit my blog with the link that will appear at the end of the video, or click on the related video, which usually is part of this series, or give you more information about the same topic. Thank you.